All right. Thanks, Joe in the chat for helping us debug the audio issues too.
Yeah, really appreciate it. Welcome to the stream. I think we're good to get started. So, yeah,
Yeah.
we're live today to discuss BQN, and Tank is going to be the teacher of this session, and I'll be the student. How do you want to start? Like, do you want to. Oh,
Well.
actually, I have an idea. The thumbnail. I don't know what it means, so I was just looking through the characters and
Oh.
I wanted to create something minimalistic, but also interesting.
Yeah.
So, what does that mean?
It just the underscore thing just means like it's sort of like a join, like a list join thing. So really, it's an array of two elements. There is all it means. Nothing too crazy.
An array of
It's
three
it's nothing.
elements.
Two elements. Yeah, two threes, like a tuple almost. You know.
Okay.
Yeah. So we actually just punch it into the editor here. So if you do 3_3 or 3 \space 3, there you
So
go.
it's backslash
3 now.
space 3. Okay.
Yep. And then shift enter, you'll see the output. It
Okay.
should just look like an array of two elements. Easy.
Okay.
So yeah, I'll do real quick. I'll introduce myself. I'm Tanker Smash. I'm just a programming enthusiast basically. I work in game dev, but previously come from a big SaaS company. I've been doing all kinds of different explorations. I really enjoyed your OCaml stream where you're teaching OCaml to a viewer, and I thought I'd maybe return the favor by doing some BQN. I'm not a BQN expert by any means. I just found it about a year ago, and I like talking about it, so I thought we'd have something in common here and get into it.
Yeah. Thank you
Yeah,
for the introduction, and yeah, I'm glad to have you on the stream. Yeah, I think we can get started now, officially.
perfect. Yeah, okay. Well, so since BQN is like an array programming language, it's sort of different than like a functional or imperative. It's like a JavaScript or a OCaml, and it's all just arrays and numbers basically. So all you're dealing with all the time is like those core pieces of data rather than anything fancy like objects or functors or anything.
Mm-hmm.
And it's really simple in its approach to things. So
Okay.
it's very cool. It's very different. So I'm not super familiar with the camel, but I'm assuming it's similar to Haskell, and
Yep.
it's all about like function composition and stuff, and you know, nice design of the data rather than you know process.
Yeah, it's more
And
about
all
describing stuff than actually explaining how to do stuff. The
exactly,
Yeah.
yeah, exactly.
Mm-hmm.
So maybe a good example for this case is a simple list of 10 elements. So if we go into the editor here
Yep.
and you type \d,
Backslash D. Okay.
yeah, and then 10.
10.
Yeah, perfect. So BQN is evaluated right to left. So the very first thing is the number, so 10, and then the range primitive there, the up and down arrow. You can see
Mm-hmm.
that it just gives you a list of 10 elements.
Okay. What is this called?
Okay. So, I
Right.
think it's called the range operator. You can hover over it, but primitive. Uh, but it'll be yeah, the names are always different. Let me pull up the name exactly. I
Okay.
call it the range, but sometimes in other languages it's called iota.
Yeah, it's called the range windows, and then I also see the backslash D here. I don't know if that's
Yeah,
visible.
perfect.
Oh,
No,
unfortunately, that's not
no, it
visible
doesn't.
because it's a native window. The
Yeah,
hover is a
exactly.
native window, and I'm just sharing the Chrome browser, so it's
Yeah.
not going to show that. Okay, yeah, that's the range operator, and
Uh,
then you do range 10. You get, I think, from starting is by default it's a 0 starting,
yep.
and then let me try
Yeah.
like how do I don't know if it's valid. Okay, no, that's not how you specify the starting. Maybe like this. Nope. Okay. Yeah, I was
No,
trying to
no,
give
that's
it
good
the
thinking.
starting point.
Well, that's actually a really good way to think about it because there aren't options to functions. There aren't like optional parameters. Basically,
Mm-hmm.
it's all just everything you're doing in these kind of languages is you're doing yourself.
Mm-hmm.
So if you want to start at 10 or whatever
Mm-hmm.
number you wanted, you
Mm-hmm.
actually just add 10 to every number.
Oh, Okay, then I assume there's some sort of a map. Oh, there is a map here. Is that the map? Oh no,
No, that's
that's the
the
key
key
map.
map. That's the
Yeah,
which is useful.
yeah.
But well, in array languages, all that the mapping happens implicitly. Basically, every function
Hmm.
maps
Hmm.
everything else.
Okay. Okay.
And so let's say we want the numbers 100 through 110, right? You'd
Okay.
add 100 to every number. So to do that, at the start of this line, write 100 plus
100 and then
and then
backslash.
plus. No,
Oh, then
just a regular plus this time.
yeah.
The
Okay.
rare regular. Yeah, there you go. Now run this
Okay.
bad boy.
Yeah.
And so what this is doing is it's generating right to left. So it's going generate 10 numbers starting from 0 through 9 and then add 100 to every element.
Also, the evaluate. Okay, that's what you said. Okay, the evaluation always happens from
Yeah.
the right.
Yeah, there's no PEDMOS or PEMDOS, like there's no order of operations. It's always right to left, unless parentheses are involved.
Mm-hmm. Okay. Okay. So
So
what
let's
I
just
was trying, was to give the starting point. Like I wanted numbers from 5 to 10.
yeah.
So
So
then, in
that's
that
basically
case, if I were to guess, uh,
yeah.
there would be some kind of a drop operator.
Oh, there is drop as well. Yeah.
Okay, so then in order to do that, that would be one of my approaches. I don't know if that's the right, if that's the best one. So if I
Yeah.
wanted the 5 through 10, then I would first do
Mhm.
this, get this, and then I would use the drop operator, and then drop how many elements? 5 elements.
Sure. So yeah, let's try that. Let's try that out. So at the start of this line here,
Mhm.
uh, do 5 and then the drop, which I think is backslash C or backslash V. I do it automatically. I can't remember. It looks like a down arrow. There you go. Perfect.
Okay. Right.
Same line. Same line. Perfect.
Nice. Got it.
Nice.
Okay.
So
Is this the right way to do it,
that's
or there's a better way?
well, it's different ways of doing it. You can do that this way, or you can
Mm-hmm.
change. You can just do a range 5 and then plus 5,
Ah, yeah. Okay.
or so yeah. And so I guess the way you'd say that is you'd say 5 plus the range of 5. Like so, you read it out loud, left to right, but it's written right to left. If
Yeah.
that makes sense.
So let me try to
So
write it. So
yeah,
you have 5 plus, and then
yeah,
you've got the backslash R. No, I forgot the backslash
D,
D. Yeah.
yeah,
And then 5.
yeah.
Yeah. Okay. Cool.
Okay, so let's assign this to a variable. Okay,
Mm-hmm.
that's with the what let's call the number range or something. Let's call it range, and then instead of equals, it's that arrow exactly. So
Yeah.
you type range or the name of the variable, and then the arrow, which is backslash left brace, I think.
Yeah.
Yeah, perfect. X is a good name.
Mm-hmm.
So variables are immutable in BQN, sort of like
Okay.
I think OCaml by default. I don't
Yep.
recall
Yeah.
specifically.
Yeah.
Yeah, perfect.
Bindings,
So
not
if you do,
variables.
oh, there you go, bindings exactly. These
Mm.
I don't think they're called. They might be called bindings as well. I don't know what the name is, but you're right.
In
Names. I
OCaml,
think they're
they're
just called
called
names.
bindings, but
Yeah, yeah. Sorry, but in BQN, I think they're just called names in
Mm.
this.
Okay.
Anyways,
Names.
so yeah, on the next line, let's just add, let's say another 5 to all these guys, or let's say 15
Using
to make a
X.
different number.
Using X.
Yeah, exactly.
Okay, so then I would do this.
Perfect. And then now, on the first line, we're going to use a system function, which is basically like a built-in named function. On the very first line, we're going to type \0 and type capital show. This is basically the print function.
Uh,
Capital
backslash.
S, like the word show, capital SHOW space.
Oh, and
Yeah, perfect. So now there you go.
oh, okay. Mm-hmm. Cool.
Okay. So cool, yeah. And it's in line too. So show is sort of, I don't know what you'd call it, but it's a pass-through function. So it returns whatever you give it. So you can actually put a show in line. So for example, between the plus and the range operator or primitive there. So between the plus and the, yeah, exactly that. Just put another show call here. Yeah, \O
Oh yeah,
Zero, sorry, backslash zero.
Oh, so
There you
you
go.
can put it pretty much anywhere.
Yeah, exactly. Sort of like
Oh.
how OCaml, everything's an expression. Everything's just a function call in here. So you can just add them all over the place.
Yeah, I think this is gonna be really helpful for debugging.
Oh yeah, yeah. It's really nice.
Okay.
It's it's really helpful for that sort of thing, because you can, if you, once you get confused, and you're getting confused a lot because this is pretty messy. Oh, immutable goat. Joe says, yeah. It'll be nice. So let's get a little fancy. So
Sure.
we want to make, let's show every number. Fancy. This is a sliding scale. So we want to show, instead of the entire array, we want to show every element of the array.
Okay, so we want to map over it.
Exactly. So let's, on a new line, on the third line, let's say, because we can leave the
Okay.
old output there for now.
Yeah.
Let's do show again.
So that's gonna be /0 and then show.
Yeah. And then we're going to use a function modifier, which is a higher order function. Basically, it just means it's a function that takes a function. So we're going to do \1. That should be to each function, the operator.
Okay.
2 then. Let's do 2 instead of 1. Sorry. That's the cells. We'll get it. There you go. Perfect. And now type x for the name of the variable. Perfect. And now what this output is, on every line, basically, it'll just print every element of the thing. And the REPL's returning the last thing you give, so you get the whole thing back.
Okay. I'm not sure if
Okay.
I understand this perfectly. So
Yeah, well, what do you think's happening? I'll walk through it.
this one is the last thing that's returned.
Yeah, that's just how the REPL works here specifically. But yeah.
So this actually is doing a side effect, right? This is actually printing every.
Yeah, show is producing a side effect.
Okay. The difference here is that for other things, I didn't really have to use this kind of an operator. So it was mapping by default, right? So 15 plus
Yeah.
is mapping over x by default, but show doesn't
Yeah.
work like that. Show,
Right.
okay, show has to penetrate inside of x and then do it. So yeah, so what is this operator doing exactly?
The 2 dots. It's doing the mapping. It's going. It's breaking down every element of the array you pass into it, and then operating on each element. So unit, or not unit, but it's called element for now. So because an array is a collection of elements, there's
What if
different
what if
types
I
of.
do this?
Yep. Try it out. See what happens.
It doesn't change anything.
Oh, we got to show the output, because you're not printing
Oh
it, so you're
yeah,
not getting any output. Well,
correct. So 15 plus.
maybe
and
let's get rid of the shows in the first 2 lines, maybe to clarify what's going on. The
yeah. So let me
confusing the
just
output a little bit.
remove this. So x, yeah, it's like this, and then it didn't change anything, right? Did it?
The first show is every, like, x is currently 0 or 5 through 10, right? And then it's 5 through 10 plus 15 is being shown on the first output.
Yeah. So no, I wanted to understand, like, is there a difference between doing this and adding this here?
Not in the addition case, not in the plus case, because plus by default is already pervasive, it's called, which means it goes down as low as it can and adds every element to every other element. So specifically for plus and minus and a lot of math operators, it doesn't matter.
Yeah.
this.
So it's basically a no op in a way. If I do it for plus, because it's already implied. So this, adding this or not having this, or not adding this, does not make a difference in certain operators. But in case of show,
Yeah.
it behaves differently. For actually showing an array, it's different, but then showing each one is different, right?
Yeah, exactly.
Okay.
That's a good way of looking at it. It's a
Okay.
good question.
Each.
Each. Yeah, each. And then the one on /1 is called cells, because there's different types of elements inside of an array.
Okay.
Okay. Uh, Now, again, let's continue to get complicated. We're going to now, instead of adding plus 15, we're going to do we're going to make a function, like a lambda, basically, an anonymous function inside of this.
Okay. I'll remove the
Okay.
show
So,
just to not pollute this.
sure. Yeah.
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 Okay.
And so let's just do, let's bring back our sum here. We're gonna make a new function where we combine a different. We're gonna make a fold basically. So you know how at the output here we have 5, 6, 7, 8, 9. We're gonna just sum these numbers up instead of printing them out.
Okay.
Okay. So let's do plus backtick 5 or backslash 5,
Okay.
and then now if you run this, you should get the sum.
Interesting.
So what this is doing is it's adding plus like a fold. It's adding a plus between every element in the array.
Okay. Can I remove this?
Yeah, if you want to, you might want to keep that definition of x, but you can remove whatever you'd like, and we can update it.
No, I wanted to try explain on this.
Oh, sure. Yeah, let's explain it. Yeah, let's see what it does.
I'll just
It's
remove
going
this.
to explain the entire algo, but and then now we have to run after you explain. It's like a toggle.
Oh.
So now run again. There you go. Perfect.
Oh, that's pretty.
So this is yeah, it's cool. It explains like the order of operations basically on how once the code gets a little more complicated, it'll make more sense why you want this.
Instead of, I'll just inline it for now.
Yeah, do it whatever you'd like.
Explain. Oh, sorry, it's a toggle. Okay,
Yeah.
so it takes a 5 and then range, and then 5 plus is gonna get mapped on this. Okay, so this one is like having a connection to this plus. Okay.
Yeah, the backtick plus is being combined into one like object, one unit sort of thing, one function, and so it's the range of 5, and then added to 5 plus, and then summed up.
Okay. Yeah, and then okay, let's get back. Right. I'll toggle explain. Cool. Yeah.
Okay.
So it's like a fold operator, and what's it called? It's
Isn't it called fold?
It's called scan.
No, that's the backtick. That's the wrong. That's the wrong angle. You're thinking. You're thinking the apostrophe versus backtick.
Yeah. Okay.
So that was the next thing.
Yeah. Sorry.
Yeah, I think fold APL, which is what BQN's based on, sort of, is what named it fold in the first place. I'm pretty sure.
Okay. Okay. So how does this
like
differ from APL? Is it
APL's APL and BQN are very similar. Just the symbols and stuff are a little more consistent, and there's a little more little like it was just made in reaction to APL in some way. So there's a lot of lessons to learn from APL. Like it's a lot more consistent, and things behave a little more consistently, and errors are nicer, and all that stuff.
Oh, okay. But on the surface, I don't think BQN does anything differently than APL. Is that correct?
Well, they're both array languages. They're both array languages, but they use, like I said, different symbols and like for example, in APL, you can choose whether the whole language is 0 based or 1 based.
Oh.
So it's called the quad IO. So you can choose like if you want to have your code or indexed at the 0 or 1. You know, so it gets pretty funky.
Okay.
But again, I'm not a professional array programmer, so if someone's in the chat and knows better, they can correct me. But yeah, APL's from like the 70s or whatever, and then BQN was invented like 2019 or something recent.
I see. Okay.
Okay, so we got ourselves a little function here, right? A little plus. Let's make our lambda.
Then it would be like again, I'll create a binding. Let me see what.
We'll do it in line for now to keep it simple.
Okay.
Yeah, and on the private stream that I can see, I only see the little tiny window. It changed focus for me. I can see your studio. I can't see the editor anymore.
Oh, you don't see the editor? Oh.
No, yeah, it's tiny now for me. I see your Discord. For a while there, I could see your. Welcome back.
I made an oopsie again. I hope you're able to hear me.
Yeah, I can see everything now.
Yeah, earlier you were able to see the stream of the stream.
Yeah, it was a little meta, but it was cool. It was cool.
Oh,
Now,
sorry. Okay, I see
no, no,
you
it's all
better.
good. No, no, no. It's all we're having a good time. Or I'm
Mm,
having a good time. So instead of doing a binding, let's do a inline variable to keep it simple for now. We'll extract it out into a name later. But so for
sure.
now, let's wrap the plus in parentheses.
Okay, this one in parentheses. Fine.
Yep. Okay, and then change the fold modifier, the
Mm.
apostrophe, into the backtick.
So that's going to be 7? No.
No, no, just a backtick. I think just pressing the key next to your one. There
Oh.
you go. And now run
So
this.
I
So
see.
this is
Mm.
uh
I
so the
understand
parens here
the.
aren't necessary. You do okay.
I understand the scan operation because of
Perfect. Versus a
I
fold.
yeah. It instead of the
Yeah,
fold is going to give you every state of the accumulator.
exactly. Yeah, and then finally, yeah,
But
perfect.
my
So,
question is,
huh?
did it have to go into the parentheses? Like how did the
No,
parentheses?
no, no. The parentheses are not changing anything. Yeah, you can get rid of them for now. We're just gonna add
Okay,
more later, so it'll be easier. But yeah,
okay,
no,
got it.
exactly. Good point.
Mm-hmm.
So bring back the parentheses, and we're gonna make it a little funky. We're gonna do some. So right now we have we're remember inside this parentheses we have a function that takes every element, right? Every pair of elements. So like the first two numbers, and then the second and third number, etc.
Yep.
So now let's do plus 10 after the original plus. So whatever number gets returned from the plus, it's going to be added to 10
Like this.
inside the parentheses. And then do instead of do paren 10 plus plus, basically. Didn't
Like
explain that very well.
wait,
Uh, inside the parentheses, do the number 10, then plus, and then plus again. It's super
like
weird to
this.
think about. Yeah, perfect. Exactly. And now run that, and we should be okay.
Oh,
So
what?
now what is happening
Wait, let
is
me.
you might do the explained. Yeah, try to figure out.
Yeah. Uh, let me. Okay, so we've got 5, 6, and then you've got
Mhm.
10 plus plus 21, 38. Hmm. It's scanning on this
Yep.
function.
And things are evaluated right to left. Don't forget.
Yeah, yeah.
And
Can I
it's
do?
normal. This is
Yeah,
confusing, but
yeah. I would. Yeah, I mean the way I would figure it out as I'll do show, and if I just do 10 plus plus and then x. Oh. Okay, so what this is doing, it's adding a 10, right? Yeah, that's adding a 10.
yeah, it's adding 10 to the result of the plus.
But then when you scan over it, does it start with a 10?
It starts with the first element in the list.
Oh, oh, oh. Yeah, I actually was going to come to that. I wanted to ask you uh, about it. So if it's a fold, then I assume that
Mhm.
it has to have a starting value. So my initial thought was that it's going to be 0, and I wanted to ask you, oh, does it just consider that for numbers the starting number is going to be 0, and now you're saying, okay, it's actually considering the first element inside the array. So what if the
Yeah,
array is empty?
I'll try it out. It should complain, but let's see what happens. Just make a instead of X, make a Y or something, and make Y an empty list.
Okay, so
Okay, cool.
how would I make Y an empty list?
Okay, so yeah, let's
I
do
can
Y,
do that.
like
Yeah.
Y. Yeah, and then the perfect. Oh, close. It's backslash left brace, and then instead of these square braces, you got to use these fancy BQN braces. So just do backslash parentheses when you type them.
Like this?
No, backslash shift 9. There you go, and backslash shift 0.
This one's correct,
Perfect.
right?
Yeah, that looks good.
Alright, so if I do Y, oh, it doesn't complain. It just gives the output. If I turn this to this identity, oh, it says identity not found.
I think that's because there's no initial element. So I think I've never actually tried this before, but if you add a 0 at the very start of this last line, I think it'll be okay. I think.
Like this.
Yeah, you go, perfect. And that basically sets the first.
Okay.
You change it to a fold, right, instead of a scan.
Yeah, I was trying to figure it out.
Okay, perfect. Yeah.
So
Yeah, perfect.
instead of the so it's, when did it say
The identity was
complain now?
scan.
Okay, so it says identity not found. So I'm just trying to think of this. Identity is defined for integers in case of addition, which is 0. So I'll tell you what I initially thought.
Okay.
In case of addition, identity element is 0, because you add 0 to anything, you will get that integer back. Right?
Yeah.
I thought the language understood it. I think Racket does it, where it automatically knows that in case of some operations, it knows identity element, so it behaves differently. I think switches behavior based on whether you give it you give it a starting element, or whether and when you don't give it a starting element. So in this case, I was assuming that it was considering 0 as the identity, and it says identity not found. So now my question is, are there things which have an identity?
Well, maybe I don't understand what you mean by identity. Do you mean like, well, I think to zoom out one level, the error isn't with the addition; it's with the fold. Fold, right now. So it's not even getting to the addition inside of it. So if you replace the 10 plus plus with just show, I think you'll get the exact same error. And I don't know if that helps at all.
Oh, can I do show here, or do I need that?
Yeah. Shows regular constant. No. It's already inside the parens or whatever. It will be folded over. It'll like won't run correctly, but you'll still get the same identity function, I believe. Yeah. Because you can see the error. It's backtick : identity not found. So it's complaining that the scan or fold can't get started. I'm pretty sure.
I see.
So that's why putting the 0 at the start of the line gives it the initial element, which then lets it understand what the first element should be.
Okay, so in this case, it does show a 0. Okay. So I think I found one more I discovered something else. Like, doing it this way is the same as applying this?
Sort of, yeah.
So let me just try this.
If you have
Sure. X,
the problem, yeah,
and let me just erase this. Oh, it doesn't. Oh no. Okay, it doesn't drill down. If I do it this way only, then it's going to. Okay. I thought it was functioning
yeah.
that when you wrapped it in parentheses, it may be.
No, in this case, the prens were just for our readability for the plus 1010 stuff. The prens aren't like meaningful syntax usually, besides grouping.
Okay, so Command Z broke, so we have to rewrite it. So it was 10 plus plus and
Yep. Scan or fold, whichever one.
yeah. Let me do this
Fold, scan. Yep.
and X.
And the next.
Okay. So it's adding 10 to every element and also adding them together, right? And then printing each state of the accumulator. Is that right?
Yeah, yeah. It's taking the first element, which is 5, and then adding it to the second element, which is 6, and then
adding
adding
10
10 to the result of that.
Got it.
Yeah,
Okay.
exactly.
Okay.
So it's composing the right plus with the left plus and 10.
Mm-hmm.
So
So
it's
this and this will automatically get composed with each other. No, not automatically.
exactly.
That's the syntax. There's no special thing. You just put something beside another, and if it allows, then they just compose with each other.
Exactly. And it goes on forever, basically. So you can compose forever. There's some special rules
after
we can
this,
get into, but that's maybe
I can maybe do like 10 minus.
so there's the trick. Okay, there's a trick to this called trains. I don't know how complicated we want to get, but if you compose, let's say, 3 functions together, they behave a little differently. Which we can actually let's do it. Let's see how this works. So do you know anything about combinators? Like function combinators specifically?
I think I do.
Like okay, yeah, I didn't, so it was all new to me. So well done. But it's basically
No, but
it messes
sorry,
with the order.
You still explain it because it will help.
Yeah,
the
sure.
others.
Yeah, perfect. So let's do replace all the 10 minus stuff and just do backslash equals or backslash question mark. Sorry, for the length, and we're gonna do the average just to make it easier to understand, because everyone knows what the averaging does. So backslash forward slash. Sorry, not question. I said question, but backslash forward. Perfect. And then do division. So backslash minus.
Okay.
And then plus.
Okay.
And wrap these three symbols or these 3 primitives in parentheses.
Okay, let me try to read this. So
Yeah, and get rid of the second set of parentheses, the 10 stuff. That's all garbage now. We're ignoring all that.
this one.
Yeah, and the scan as well. The fold. Sorry.
Okay. So,
Yeah, perfect. Yeah, try to read it.
Yeah. Plus, and then divide, and then not equal to.
Close.
No. Obviously, it doesn't make sense because this I know is going to get applied to every element inside the X, right?
Yep. Yep.
But these are binary operators. But then at the end we do have, I mean, all of them actually take 2 things. So I'm not really sure how it's going to work out.
Yeah. Okay. So this is you're right on the path. So binary and unary, let's say.
Yeah.
For one argument, 2 arguments. Yeah. So in these kind of languages called monadic and dyadic, but the exact same meaning. So because every one of these functions primitives have overloads for unary and binary calls.
Oh. Okay.
So in this case, the not equal sign is actually using unary, and it's the length function. So it's the number of elements inside of X. So if you get rid of the division and plus, we'll just validate that. We'll fact check that. So if you hit delete twice, perfect, and then run, we should see 5 because there's 5 elements in X.
I can do this without the parentheses also, right?
For now, yeah. But once we add the 3 functions
Yeah,
back, you
yeah,
will need
got
all
it,
3.
got it. Okay, okay.
Okay. And then likewise with the plus.
Just the plus?
Oh, did I mess this up? Sorry. This should be a plus fold. Sorry, plus fold. The fold has to be on the next to the plus in this case.
It, like this?
Inside the parens. Sorry. Inside the parens.
Oh. This is the fold, right?
Yeah, \5, I think.
Okay.
Yeah.
Plus and fold, and that gets applied to each element in X.
You got to run this though. You haven't run it yet, I don't think.
Yeah, I haven't run it. I was just trying to think how.
Okay. Oh, sorry.
Yeah.
Yeah.
Okay. What's happening here?
So
is it
I
also
think you
using
basically had it.
fold? Is it also using like another variant of fold, an overload of fold?
No. This is the same sort of fold you've seen before, like you've seen earlier today. Like
Okay.
the folding all the 5s together, or all the 5 elements together.
Yeah.
Okay, good. Now let's bring back our length function and the division function and primitives. So backslash,
forward slash, and then backslash minus,
right, and just
then plus.
Yep. Perfect. And so we know individually what all these do, right? We know that the not equals is actually the count, the length, and then the backtick on the plus. \5.
Oh. Okay.
Perfect. So we know that the plus fold gives you the total.
Yeah.
We know that count gives you how many elements are in X. And this is where it gets tricky. The division is the division. So it does, dividing 2 numbers.
Length
So we
by
sum this up.
length by the thing, or yeah, okay. Oh, it's actually like the binary operator takes the left side and then divides it by the right side. Hello?
Yeah. Sorry, I realized we. Can you? This is messy, but let's do after the division. Hit \tilde. We're gonna get a little fancier. This is pretty, and then hit run this, and it should be a higher number here.
Yeah, I got it. So
I got 7.
I think I understand. So divide in this case is actually whatever you're getting equals is a length operator. So this one is going to be length, which is 5.
Yep.
And so the right side is the composition of addition with the fold. It's going to be the sum. So it was doing 5 by 35, and then this one is like the flip operator. It's flipping
exactly.
It's flipping the divide, and it does 35 by 7. So it's like takes the right and then divides by the left.
Exactly.
Okay, but I think it's going to be a wild ride to understand the semantics of how these get applied. Like this one is getting applied to the divide, and this one is getting applied to the plus, and not really something like this. You see what I mean?
No. Yeah, exactly.
Yeah, I'm just saying, like, it's going to be, I think, a big learning curve. I mean, a hard learning
that is
curve
definitely
to understand the associativity of these like operators.
Exactly.
Okay.
And the way to the easiest way to remember is it just binds to the left. So it always binds to whatever is to its left.
Okay. Yeah, but how much? So binding to the left. There's so many things here. Like how many? Only one character bind to the left?
Only one. Only one. Yeah.
Okay. Then that's not that difficult.
Yeah. Well, it's really weird, but it's not difficult at first, or not as crazy as it seems.
Yeah.
There's no order of operations. Basically, it's always
Mm.
just what you
Right
choose,
to
what you
left.
get, right to left.
Okay.
But
Cool.
yeah, these modifiers,
Mm.
these if they're syntax highlighting, these would be uh, what's it, pink, I guess,
Yeah.
because they're taking a one function and modifying it,
Mm-hmm.
whereas
Yeah.
the uh, whereas the yellow ones there, they take two functions instead of one,
Okay.
so they go between two functions.
Mm-hmm.
So anyway, back to the original average thing. So what this is doing, it's a train, they call it. So it's taking three functions, a three
Yeah.
train. It's taking three functions: the length, the division, the plus, the sum, I should say, and then doing the first and last one first, and then the middle one after with the result of these. So it's
Mm-hmm.
taking the monadic length, the monadic sum, and
Mm-hmm.
then the binary division.
Okay. And also the monadic length.
Yes, monadic length and monadic sum.
Is it really called monadic? That's.
Yeah, monadic dyadic or unary binary. They're
Oh.
two different. It's Greek and Latin or something. Greek and something else,
Uh huh.
but both exactly the same meaning.
Okay. I wonder if it has any relation to monads.
No, zero, zero.
Okay.
Some
Uh.
languages have a niladic, which is no argument functions.
Mm-hmm.
Not BQN though. BQN always has an argument. Okay, so this is a train. So if we want to instead like change any part of this to get instead of a sum, we want to do something funky like add twice. We could just make a new function inside of these, yeah, and add
Yeah.
parens around
So
plus.
can I do like oh,
That feeling is very
backslash
common.
backslash 5? I actually forgot where the backslash is on my keyboard.
You've done really well with the keyboard so far.
Oh, thank you. So 2 plus, but this is not. This is probably not going to work. I need to do it this way, right?
That
No.
depends what you're going for. So,
Wait.
well, that's okay. You can bring it back. I'll show you something else.
Hmm.
So bring the parens back around 2 plus.
Okay.
Because what you're trying to do here is I think what your intention was is to make a fold that adds 2 to every number, right?
Yeah.
Yeah. So between 2 and plus, we're going to add in a dyadic, a 2 modifier, and put after the 2, hit backslash h. I think it is. Yeah, between the 2 and the plus. Now, this 2 function modifier takes a left and a right thing and joins them together, basically. It's sort of like a partial application, almost. So what this is saying is return a new function that
Mm-hmm.
just adds 2 to whatever its right argument is.
Okay. Okay.
And it's ignoring the left argument, so you're really just, if you think of it as ignore whatever the previous result was of this fold and just add 2. So it's really just adding the last element plus 2.
Mm-hmm.
If you want to show that on its own line, but
Wait, let me add can I add a show here?
yep. But you have to add more parens and stuff. It'll get a little messy, but we can do that. So before the show, yeah, exactly, and then after the fold, perfect. That should show it.
Mm-hmm.
That should be
So
good. So 17.
yeah. Just adding 2 to every element and then summing them up. Right? And is that what's happening?
No, isn't it saying 9 plus 2? No, it's not.
Hmm. The sum is too low.
Yeah, I would have thought it was 9 plus 2, but 9 plus 2 is 11,
Oh, is it
not
dividing and then
17.
showing the result?
No, it's showing first.
Hmm.
Put the show after the 2, or sorry, before the 2 as well. This is now. I feel like I should have known this, but like before the number 2.
Oh, here?
Yeah. Put another show. We should see a bunch of prints.
Like this?
I might need a space. Yep, and then there you go. Yeah, 5 plus. Oh,
Yeah.
X isn't 0 through 5. X is 15 through 19. Yeah. Yeah, so it is the first element plus 2. Yeah, is what I thought it was. I'm Wait, is it?
Is no, X is 5 through 9. The second one is actually adding 10 to it.
Yeah, which doesn't matter at all. So how come there's 11?
It is 11.
Okay, get rid of the length and the division swap, and just to keep it very, very simple, just to remove things. It's still 17. Huh. Well, I have no idea what's going on.
It's a debugging session.
Yeah.
Okay, so actually, I'll bring this back, and the way I would try it. What is the? How do I type the?
Backslash L, I think, or H. Sorry, backslash H.
And then
It's
plus.
two directions.
Okay. And this one is X.
Yeah.
It's adding to. Okay, here. Oh.
Yeah, that's adding 2 to every element, but it's. If you do that, is it going to sum it?
Yeah. Sorry.
No, you did the right thing. I'm just.
It's summing. It's. Oh, but
But how is it?
17.
That.
If I do this, this is
Yeah.
adding 2, which is fair.
Yeah, which is what it makes perfect sense.
Then when I add
The
maybe
fold.
the fold.
Oh
Oh,
no!
it's
Now you
folding
change to
5.
scan.
Now
That's
what's
cool.
happening?
Okay, if you explain it, let's see what happens.
Okay. And then run it again.
Yeah, and just see at the very bottom. Well, we get the second line that's thrown out the output, but it's just it's 2 plus and folding. Huh. I'm very.
Yeah, it is surprising.
Yeah, what is actually? I'll look up my own here. What's the monadic version of plus? Conjugate, the complex conjugate of x. I don't think that matters. Huh.
Do you want me to open a link that you shared?
No. We're good. I think maybe we'll just think about this after and let it brew in the back of my head because something's really. It should be really obvious to me, but I'm not. It's not clear why it's 7.
Okay.
I would have thought this was just an add 2 to the result of whatever the final one is, but it is not.
Okay. Let me remove the
There you go.
shows.
Learn some. Yeah. Having fun. Like I said, not an expert.
Yeah. This is not what we're expecting. So let's actually
No.
remove this.
Yeah, this is back what
we're
we were expecting. Yeah, the average of 5 through 9 should be 7. That sounds right.
Yeah.
Middle-ish of 7.
Okay, that actually looks good. Divide, fine.
Yeah. So the pren inside of around the plus is optional, so we can get rid of that too. To even tidy it up a little bit.
Yeah. Okay. Although
And then we could also.
I had a
Oh, yeah, question?
Yeah.
Yeah.
How does
What do you got?
So if I do 5x. So in this case, it's starting from 5 and then summing things together.
Yeah.
How does it matter if I mean, what if I do this? So I wasn't having a clear understanding of having it as a function, like here. You see, earlier we had this attached to the plus and not really here. So does this function the same? Okay, it functions the same.
Yeah.
So with or without functions the same. But if I were to do it this way,
I would expect this to be exactly the same as 17.
Same as 17. And then it doesn't matter where I put these brackets.
No, so the reason that the brackets matter is because there's something called I think it's a subject expression versus a function expression, and it's basically if there's a number or value on the very right side of the line, that becomes the subject expression and it becomes like a calculation. Whereas if there's no subject and it has like on our sum there, our length division plus, that has no subject inside the parens, so it's a function that it builds, so it doesn't count. So when we have I don't know if that makes sense, but because there's no number, there's no value on the right side of it, it makes a function, and that function is getting called on X.
Oh, okay, got it. I think I got it.
And that function can be pulled out into a variable, and it'll work exactly the same.
Okay.
So when you add the parens anywhere on the last line there, it doesn't make a difference because it's already evaluating.
Yeah, I mean before the last character, you mean?
Yeah.
So, if I understand correctly, if I just pull this into a variable, let's say f, and then I do f, how do I apply f to x?
How you have it now, except f has to be capitalized when you call it. It has to be capitalized. No, a lowercase name is fine, but when you call it, it has to be a capital F. There you go.
Oh,
and then, and then also call it F. You're right, sorry. Call it F as well, capital F. When you name it, on line 3. There you go.
Undefined. Oh, but.
And then you put a space after X. Between
okay. That's okay. Okay.
So, it's functions and stuff are case sensitive in BQN. So you can call it a lowercase f if it's like a variable, but then you can call it as a function with a capital F.
I see.
Kind of.
Got it.
Context free grammar, etc. Okay, so now to simplify our sum expression, we can just swap, like move the count and the plus sum on opposite sides of each other. So to get rid of so take you follow that so far?
Yeah.
Okay. Right. This works exactly the same. Now we can add a fourth function. The fourth function will be applied unitically to the result of this. So we can say put like negative or something. Put the minus sign, and that'll give us -7.
-7. If I'm not mistaken. Okay.
Yeah, because it's a fortran now.
It was able to understand and deduce that this operation is going to give one value, and this is going to have to be unary. Is that how it's working?
Exactly. So a train that's larger than 3, so in this case it's a fortran, it gets parsed down into 3 or 2 trains, and because there's only a 3 to the right of it, the 3 train gets collapsed into a single function, and then you have 2 functions next to each other, the minus and the result of that function, and that's just the unary chaining. Okay.
Yeah.
So you ready to get a little fancier?
Sorry?
Are you ready to get a little fancier?
Sure.
Okay. Let's do let's make numbers 0 through 25.
0 through 25. Okay.
Yeah.
So that would be the range operator, which is D, and then 25.
Yeah.
Okay.
Exactly. Perfect.
26.
Now. Sorry, I meant the first one, but this is good too. Actually, no. Make it 25 because we need to have a 25 number specifically. So now let's reshape it into right now we have a flat list, right? We want to make we have a flat list. We want to make 5 rows of 5 elements each. So we're going to use the reshape operator or reshape primitive, which is Z. And then at the start of this line, we're going to give it a new shape that we want it to be, which is going to be 5_5, like the backslash space. It's called strand.
Okay, got it.
Yeah, if I was smart, I would have done 3x3. Now, if you run this, it's going to reshape our thing into a new array now of a table, like a 2-dimensional array.
Okay. Oh, we can do this too.
Yeah, you can put any size.
Ooh.
And it'll fill. It'll take forever.
Oh,
So
but
you can
it
put 1,000 or a
repeats.
million. Or
But it repeats
yeah,
the once it runs out,
yeah.
it repeats. Okay. Mm-hmm.
And so the good and bad part about these array languages is there's a lot of like implicit knowledge that comes into this. So like it won't often things won't error out when you expect them to. Like in this case, because you
Mm-hmm.
allowed it to take more than the length was, it'll just say, okay, cool, I'll just start looping.
Yeah. Okay.
So now, before the reshape, let's do the drop. Let's do our like before the drop. Sorry, before the reshape gets evaluated, let's put a drop like 10 in there just to see how that would work.
A
We
drop.
do,
This one.
yeah, I think it's \c, and then let's do a drop 10 instead of nothing.
10 drop or drop
We want to call
drop
it
10.
a 10 drop.
Mm-hmm. Okay, so it will
So
start
that
from 10, then go
exactly.
and put it. Okay.
And then, of course, this changes and everything else. So if we want to do the length of this thing, we can, or the sum or whatever. You can just keep chaining to the left. So if you put after the 5 by 5, you put whatever else math or whatever you want. It'll work. So if you do like 10 plus, it'll do 10 to every element in there.
What if I just do plus?
It'll do the conjugate thing. You can try it. It should do nothing.
Conjugate.
But
What's
just
a
because
conjugate?
it's some math thing I don't understand.
Oh.
It's the complex conjugate of x, which some imaginary number thing. I have no idea. I'm not a
Oh
math
yeah,
guy.
yeah. It does remind me of some complex number lectures. Okay.
Yeah, I don't know anything about that. Yeah, just imagine eyes in there or something. I don't know.
Okay. Okay.
But if you add like 100 to this, like 100 plus, and then it'll add 100 to everything, as you can imagine, because it's pervasive, like you said. So it'll do it, no problem.
Okay.
Okay, so because this is a two-dimensional array, right? We have length will give us. I think it'll give us 25 if you do the not equals at the start of this.
Backslash equals? No.
\/
Okay.
So instead of giving you 25, this gives you 5 because there's only 5 rows in this table. So now this thing called shape. So instead of not equals, let's do \m.
Oh, it'll be 5 by 5.
5 by 3, I think, or something. Yeah. Shift M. Sorry.
Oh. So yeah. Okay. There's meaning in the symbol also. It's
Exactly,
not equals, and then
yeah.
you have another line in the middle. Okay.
And this is of course a 5 by 5 list. Table. Sorry, a 5 by 5. And
Okay.
the shape here is again just an array, so you can mess with this the same way you would, but we don't need to get into that. So let's get rid of the shape primitive we just added, and let's do yeah.
Shape or the okay, yeah, this sorry. Yeah.
No, you got it right. Well, any questions so far?
Nope.
You're doing really well, by the way. You're picking up stuff lightning fast.
Thank you.
Okay, so let's do take not take I don't know what it's called, get maybe \i.
\i.
Yeah, and then if you imagine what this will do, could you guess before you're running it for the first time, knowing nothing? I'm giving you something harder to imagine.
Yeah. No, I appreciate it. I actually enjoy trying to guess stuff.
Good.
Take. Let me see. What does it say? This looks like the belongs operator.
Okay.
And maybe it's gonna give me like the first number.
That's pretty close. Let's try it out and see what it gets.
First row. Okay.
The first row. Yeah. Okay.
It is the first element in this one. Okay, because I think
Exactly.
I got it. So this one is actually giving us a length of 5, which means there are 5 elements, and this one is actually giving us the first element.
Yeah.
Okay.
Yeah. Then there's some technicalities there involved because you can do now instead of \i do \shift_i.
Yeah. So it's like the reverse of that, maybe. Oh, this is
Right.
equal to, so shift I, first pick. So this will probably dig as deep as possible and get the first from within. it. Yep, that's right.
Yeah, exactly.
Okay.
Exactly.
Okay. It's
Oh,
intuitive.
yeah, it's kind of cool. It's kind of neat when you start to understand things. So
Mm.
now let's, instead of picking the very first one, let's just pick the seventh one.
Mm.
So put seven
Yeah, 7. Yeah,
in
yeah.
front of the.
Yeah. Must be a list. Maybe no, second level parts of a train must be functions. Hmm.
So run it again to get the error, the initial error. No, this is fine. You can do what you're doing.
Okay. So must be
So
X must be a list. Okay, that's not a list. Oh, maybe no. Must be a list when W is a number. W is a number. But
yeah,
this is not a list. This is an array.
yeah, exactly. It's it's a table. An array. Sorry, a list is a one-dimensional array, whereas a table is a two-dimensional array.
Mm-hmm.
So it's basically saying I can't, I don't know how to deal with this because there's two dimensions and I can only deal with one, basically.
Okay. Okay, got it. So we gotta convert that to a list. I don't know if that's the correct way to do
Yeah,
it.
yeah, exactly. So we can actually do something called D-shape, which is just reshape without an argument. So it's a monadic, or what you call it, unary reshape.
Okay, so for reshape, let me try to find the symbol for it. So we've got this one, and where is it? It's okay. It's here, and maybe this.
That would work too, I think.
No, it doesn't work.
Oh no,
Incompatible
okay, never mind.
emblems.
It's got to be folded, but that's fine. You can either fold that or just use the D-shape, reshape primitive.
Let me try to fold it. Oh, must be a list. Nah.
Really? Okay. Okay,
So
do the Z one. There you go.
capital Z.
That should be it. No, lowercase Z. You have it. You had it the first time.
Oh, but that's also the same operator we're using here, right?
Yeah, the same primitive, exactly. But we're using it dyadically or binarily. Now we're using it monadically, unarily.
Oh,
Like
okay.
because the left of it is a 5_5 or 5 strand 5, whereas now the left of it is a function, which means it's not passed in as an argument.
Uh huh. Okay. Oh wait, sorry. Can you repeat this? How is this unary
Yeah,
now? Because it is. This is the
because
argument to this,
everything.
right?
Yeah, it's left argument exactly. In
Okay.
BQN, all functions take two arguments,
Mm-hmm.
one or two arguments. So
Mm-hmm.
because this is given a left argument, it's being called binarily, so
Mm-hmm.
dyadically.
Mm-hmm.
Whereas the D shape, the second one we used, there's no left argument because the left argument is a function,
Yeah.
and so it's not actually being called because it's not a modifier. It's not like our cells or our each function. It's
Mm-hmm.
just a function, and so two functions don't talk to each other.
Mm-hmm.
So if there was a number or a variable on the left of the second D shape, we would be using it dyadically. But
Okay.
ask another question. It's a kind of a weird thing, but
Mm-hmm.
please ask another clarifying question.
Yeah, of course. I mean, if I don't understand if I don't understand anything, I'll definitely ask a question.
Good.
Okay.
Good.
Yeah. Mm-hmm. A little bit on the motivation of these languages.
Yeah.
Where are these applied? When do these make sense?
Uh, well, the biggest sector is the financial sector for sure. So a
Mm-hmm.
lot of trading companies and stuff. I was listening to a podcast for a different language is used in the energy sector, I guess, for balancing power consumption or something. I'm not exactly clear, but
Mm-hmm.
anytime you're dealing with numbers is a good use case for this stuff.
Okay. Okay. So, uh, if I remember correctly, you said like everything is number and everything is a number, and then you have arrays of numbers, and then you have some modifiers and functions that operate on arrays. That's the whole. Uh, that's all that you have in these array languages. Is that correct?
Pretty close. Yeah, everything's an array, even the number. But yeah, exactly. Almost everything's an array.
Mm-hmm.
There's some examples like you have namespaces and stuff, which can have like members and stuff, but generally everything's an array. So when you're like dealing with like a CSV or something, you every column would be its own element in the array, and every row would be a row in the table. Sort of like we had a 5 by 5 thing. And
Okay. Okay, got it. And I believe there are also strings. I don't know how these operations work
Yeah.
on strings.
Okay. Yeah. Let's try it out. Let's make X instead of numbers. Let's make a word like hello
Yeah.
or something.
Yeah. Let's make it like this.
It's a great word. It's a great word.
Would this work?
Okay. So yeah, of course.
Okay.
Okay. You can also run math on these because if you remember, characters are just like ASCII. So if you do +1 to everyone, it should shift all the letters over by 1.
But software question, like how does it work on UTF-8?
I actually don't know how it handles UTF-8. You can try inputting it. It might actually go kaput. I don't know. If you do,
Let's use the same characters here.
sure.
Okay. So you
Okay.
wanted to do one plus. Actually, before I do this,
Yeah.
okay. So I want to just apply +1 on tank and see what happens. So
Sure.
in strings, like how do I index? Like how do I get just this part?
Take. Take the first 5 characters.
Okay, so take,
Or
if
4.
I remember, wait,
Yep.
obviously I will not remember the binding, at least the operator, is this take?
No,
No,
it's color based. So green are functions, yellow is 2 modifiers, and pink are 1 modifiers.
Yeah, so you already brought that up before I asked, like I was delaying it too much. So I wanted to understand like these color codings. So this is for monadic functions? I don't know.
They're regular.
Argument.
They're primitives. They're functions that deal with data, basically,
Oh, the
like
green ones.
arrays and stuff.
Okay.
Yeah, the green ones deal with data, I guess, and then the pink and yellow ones deal with functions.
Pink, yeah, I've used this one, which is like flipping the function order or function argument order.
Yeah.
And then
Yeah.
dot, dot is the, I don't know if I used
No,
this dot for the show. I used this.
No.
I used this dot for a show.
Yeah.
Okay.
Which is the system function thing.
Yeah. So all of these deal with like assigning to a variable. I mean, to
Yeah.
giving it a name, and then this one I don't know. This one I've used for show.
Well,
Okay.
different dot, but yeah.
Yeah, and then the take you probably is from here. Take we already this one is the take, right?
No. Sort of. It was get, but we've used drop. We haven't used take yet.
Ah,
Drop is the down arrow, but if you can imagine what the inverse of
yeah,
taking
this
dropping
one.
would be.
This one. Okay,
There you
so
go.
up arrow, and then we actually want to take first 4 of y.
Uh-huh.
Oh,
Nice.
that first if I do
4.
first 5, okay. Oh, it's actually dealing with your TF8. I don't know where in the, I mean, how
It's gotta be
wide these
unique.
characters are, how wide these characters are, but fine.
Uh,
Takes.
do you have a
this is
keyboard
working.
that can
Sorry?
add other characters? Do you have a way to add it, like wide characters? Like I don't know what a way to. Do you have a sample character we can test? Yeah, there you go.
Yeah.
Can you put that in the string and see what happens if it handles those correctly? I'm actually not sure myself.
Mm-hmm. We're taking
Yeah.
only 4. Let me take 5, and then 6, and then maybe 10. It's handling correctly. Oh, I want to do one more thing, which is
Yeah.
length. So length was this, and if I do what, okay, and then if I paste this one,
We expect to see 5 or whatever.
No. Okay, so it's actually doing it's handling UTF-8 correctly. I mean, given that their
Nice.
own characters are UTF-8, I think they
Yeah.
ought to handle this.
Yeah.
Okay.
That's good. I never tested it out.
So, but
Okay.
we still have to test like what happens when we add one to each of
Yeah.
them, right? So here, let's take four of them, and I want to
Uh-huh.
add one to each of these. So we maybe like
Sure.
one plus.
Yeah. Oh, you don't need the prints here.
Oh,
If you get rid
secondary
of the
parts
prints.
of a train must be functions. Ah,
Yeah.
so
Remember because
I
we
need to
talked about.
do these.
Yeah. Exactly.
Oh, I don't need the parentheses.
Uh, no,
Oh,
but even with the prints, with or without the prints, it would do the same. So you add them back in now that you've made it a single function because you've used the to modifier to build a single function for two functions.
okay. So it doesn't matter whether I put it or not, right?
In this case, no.
Okay. So TUABNOKL, which is expected. But what if I do this? Oh, it's like
Okay.
doing the next.
Yeah. It must be the next Unicode number.
Ah, next Unicode
Does it?
number. It's
Is it?
not actually adding one to it. It probably. That's interesting. Is it the next Unicode number? If it is, then yeah, I don't
Well, it for
really.
sure is for ASCII. It for sure is for ASCII, but I don't know about how it works up in the Unicode numbers.
Yeah,
Because
it's
like
working.
if you do, yeah.
Yes. What do you want me to do?
No. I was just gonna follow up that. Like if you add one to the character A, it'll become B, like we saw. So it works even for caps and all that stuff. So if you have like
Okay.
capital A, and then plus one, it'll be capital B, for example.
Yeah.
And then I guess to plus on that actually, we can do we could do
Okay. Now it
the
worked.
range of 26. Oh, that just spaces, which makes sense. No, it doesn't.
No, it doesn't because this
Yeah,
it
surely.
really doesn't have a printable character at some points, right? Um. Yeah, there's definitely a lot going under the hood because it's not just adding plus one in other cases. This to me shouldn't really be defined for strings because adding one to a string
Hmm.
really, I mean, a character doesn't make sense when you go up in the character world, right? With
Yeah,
UTF and whatnot.
yeah, probably.
What are the semantics? It's
Probably
not
not.
really well defined.
Well,
Okay.
yeah, maybe it's fine. I just don't know about it. But if you do range of 26 or something, and then add A to it, you should get all the letters of the alphabet, the English alphabet, Latin alphabet.
Okay. Yeah, I mean that's understandable. We get that from here, and we probably assume that it's the next Unicode point, and fortunately they are
Yeah.
printable and it's working. Okay. But we could actually test that. Alpha. How do I type alpha? A beta. No.
Oh,
It's
is
actually
that?
yeah. It's probably not working the way we expected. I don't know in UTF world whether gamma comes after beta, but yeah. Anyway.
Yeah, you think it
Okay.
would. Well, let's actually just check with the well, no, not check. Let's try the range 26 thing for the alphabet. Let's just get that going first. So we can do some math on that real quick. So do the range 26, and then plus one, or plus A. Sorry. So
Oh.
range
So
26.
range was D, 26.
Yeah,
And then
and
A
then
plus.
character of A. Yeah, the single characters, single quotes around A,
Yeah.
and then plus. And this is going to give you the near, yeah, you got the alphabet.
Okay.
And then I think you can do, is it 60? How many, I don't know, I'll ask you well enough, but if you add 60 to all this, it should give you the capital numbers, right? Like there's some offset away from each other in the
Yeah,
ASCII.
we need to subtract
Code.
it. Yeah, let me try to do that. So I need to. Oh, so do I need to compose now? I want to subtract 65 to this. I mean, not
Well,
65.
just pretend it. 64, 60, whatever.
No, I can just
Well, let's try it.
I can just do this minus like this. Like I don't know
Oh,
how
yeah,
this.
does that work? Well,
It does.
Let's see.
No. I probably have to
Then
flip
swap
it.
it maybe.
So yeah,
Yeah, yeah.
for the swap,
A tilde.
just
A
not
backslash
this
tilde.
tilde. No.
Not shift, just backslash tilde.
Just this. I thought the
No, no, it
one.
should be high. It should be pink.
Oh yeah, so it's not the backslash tilde. It's not the tilde then.
That,
Oh,
there.
so
Well,
we. Well, no, that's not what
here,
we
let me
wanted.
just run something up quickly here. I'll just look up what the ASCII of
No, I
lowercase
know
a is
it's
97.
it's 65. I know it's
Yeah,
65.
yeah. So the difference between the two of them is like 30 something.
Yeah. What would it be? 32.
Yeah.
Yeah, 32. We got the differences.
Yes,
Oh,
we
we
want
got the
to
differences, and then we want to add
32 to everyone. Like if the distance between A and A is 32, don't we just want to add 32?
No, actually, we want to subtract 32 from this again.
Okay, then change the uppercase A to 32. The uppercase one.
Oh, but like I wanted to do it like the composition. Like let's go from here, not modify this. Like I get this now.
Oh,
Now I want to subtract 32 from each one of these. So
okay.
let me
Yeah, yeah, okay,
X.
yeah. I see what you're going for. Yeah.
I forget the binding for this. Let's call it letters. I can have these names, right?
Yep, yep.
Yeah, it doesn't make sense. Y's, and then from. Okay, it prints the last assignment. Nice. Then I actually want this one also to be.
Oh no, you can keep it on the same line. Look, keep it on the same line. Be a array programmer.
Oh, so like this?
Yeah.
Oh, what's the binding for this? Okay,
Back
open.
quotes or something.
Okay.
There you go.
Okay. Okay, letters. We've got the letters, and then from each letters I subtract A, and then I need to subtract that from Y's.
So the letter is minus. No?
Yeah. Wait, so I need to subtract this. I've got this array, and then I've got the letters, right? And I basically want to subtract this from that array.
Yeah, every element of Y's from every element in letters.
Yeah.
Yeah, so do Y's minus letters.
Oh, it automatically does that. Okay.
Yeah.
I probably have to do it the other way around. Maybe I'll use a flip operator. I know I'm abusing this.
No, dude, this is exactly how that we used. It's this stuff. So,
but actually,
the reason this is
I just need to do 32 minus. Yeah, of course, like it's everything's gonna become an A. It was my brain being
it's all the distance from A. Yeah.
So this one, I just need to. Yeah, I'm not trying to be efficient here. I'm just trying to see like.
No, we're having fun. We're learning.
Yeah.
This makes sense. This is how I learned too.
I need to just take this. Let me just take this. So I take the first element. If I remember, is this how we do it? Oh no, this actually works on I think arrays only. Sorry, matrices. And the take operator
works on everything.
It down. Yeah, it works on everything, but it looks to me that it's like
it's wrapped. Yeah. It's wrapped in a unit array or something. It's there's some word for it. But yeah, it's not the element. It's like a single element array.
Okay, I take this and then I subtract this from letters. Sorry, I don't think that's right. Maybe
I think that's right. Oh,
Oh, letters, double subjects, missing.
yeah. So there's two values next to each other, and that doesn't work. So you need to have a function between them.
So I need to
Because
map.
the
So
one minus. Do you? No, I don't. I don't think. What are you trying to do specifically?
I. Oh, why is it one minus? I just need to subtract whatever this value is from letters. So
The
that
first
was
element
actually
from
done.
y's.
Wait. Sorry.
Without.
Yeah.
Yeah.
So this is
Yeah.
the. Oh, this is not actually the first value. This is an array of
Yeah. That's
32,
the.
right? How do you
Yeah.
get the
It's an
first?
array of. No, that is the first. That is the first element. You're taking the one element. Like you're taking a list of one
Yeah, but it's not
from
really
y's.
32, right? So this is different from this. So I'm taking one element.
Yeah.
Oh, but I got one, and
Yeah.
then
Oh, I see. Yeah. Go back to the pick. Shift I instead of take. I see what you're saying.
oh yeah, okay. This one, yeah,
But you want it
yeah.
instead of the first one. You want the 0th one to be like the actual first.
Okay. There is no 0 1 switching like in APL in this one.
Not in BQN. Yeah. Exactly.
Okay, fine. So I got this one, and now I need to use this
Uh-huh.
value and subtract this from
Yeah.
letters,
Yeah.
and maybe like this. I don't know.
Okay. Close.
Maybe I need this function. Wait, can only negate numbers. Second level parts of a train must be functions. Okay, I need to. I think I need to use this operator. No, can only negate numbers.
So the answer here is you want to move the minus out of the parentheses because you want to evaluate like the 0 index y's and then subtract the result of that to letters.
Ah, but it still says something. Can only negate numbers.
Yeah. Actually, I'm confused. What? What?
Let
Can
me.
you show letters before you subtract it? Just put a show between the minus and letters.
Oh no, it's D.
A 0.
0.
0.
Show.
And
Oh,
then put
yep. So it's got it. So obviously, yeah, this is not going to work out because this is 32 and I cannot do 32 minus. It's weird because it was able to add +1. Can I do? We did this, right? So let me actually. How do I comment here? What is the comment?
It's hashtag, I think.
Okay, it's hashtag. Fine. If I do +1, sorry, 1 plus, and then I do letters, it worked.
Yeah, but then how come minus doesn't work?
Oh, but yeah, it's just how it's defined. Plus is defined, minus isn't. I cannot do. Yeah, let's say I do this,
No.
but I cannot do this 1 minus. See, can only negate numbers. Is there?
Swap the minuses. Oh, you did already. But swap the minus, and that'll work. Because it's 1 minus a or something, and you can't go negative. I guess this should be fine, right? Yeah.
Oh. Ah, okay,
Yeah.
okay. So I just need to. Yeah, I need to do. What is the key binding for this? Okay,
For what?
backtick. And then if I do this, and then I do this. Okay, we got it.
Nice.
We show the letters. Just curiosity, what's gonna happen?
Yeah. Because you're taking the first element of the result.
Oh. Okay, got it. So letters.
Because
And then
you're doing basically y's minus swapped letters, and you're taking the first element of that.
or maybe this will help in this case.
Sure. It's
I
tough because
wish
there's a
it.
lot of like we don't use X. Yeah,
Yeah, I
I
wish
know
it
what
could
you're saying.
just show the last
Selection or
part.
something.
Oh,
Yeah.
can it do
If you get
that?
rid of you don't use X at all, so you can get rid of X from the test here and just make it simpler when you explain it.
Mm-hmm.
Same with the second line too.
Tank also. We're not using any of this.
Yeah, there you go. Yeah, simplify our lives. There you go. But still, it's the second chunk here you're looking at.
Mm-hmm. Yeah, this one.
So right to left, it's showing letters.
Mm-hmm.
Then it's calling the swapped minus with Y's and letters. So it's really being letters minus Y's.
Oh, so
Then
it's
it's
like
taking the first element.
letters minus Y's. Hmm.
Because if you get rid of the show and get rid of the zero take, well, maybe we can simplify our lives a little bit, and we can. So this is
Yeah.
what you're getting the result of, right? And then that should be A through Z. Oh, whoa. Oh, Y is 32, right? So letters minus 32,
Mm-hmm.
right?
Yeah.
Why is it all A's then? If that's the case, actually. Can you just print out Y? Just type Y's like YS and then enter or shift enter to see what the output is. Is that numbers going up?
Yeah, it
That's the
goes
distance
up.
from. Okay, that's why.
Mm-hmm.
Yeah. Okay, that makes sense. Yeah.
Yeah, because it's 0 through 25, and I do 25, not 25, and then I add 97 to it, right? And for each of them, I
Yeah.
subtract 32. Ooh, so obviously it's gonna go up. Okay. Hmm. Yeah, got it. I think I understood what's happening.
Okay.
If I, yeah, so it's basically getting this and then taking the first element from there. Okay, fair enough.
Okay.
Yeah, then if I do
Let's.
the, if I bracket this, then it's going to be 32, and then 32 is going to be subtracted from each of these letters, and we should be getting the capital letters. Perfect.
Yeah.
Okay.
Okay. How's your you ready for more? Or are you ready for calling it? What are you thinking?
I'm
There's
actually,
tons more we can do.
yeah. What about these red ones? So we've used this, and we've used these. We've used this one. This one I don't think before or buying. Can you explain a bit more on these?
Yeah, I'd love to. So, uh, if let's go make it a simple one again. Let's go numbers 0 through 10.
All right, so it's gonna be range 0 through 10.
Perfect.
Okay.
Okay. And now let's on the left of this guy, the
Mm.
result of this, we're gonna just
Mm.
do let's do I think three. Let's do three. Right number three. So now this is Windows of 10, I think. So if you run this, length
Length
of
of
W must be over. Okay, sorry. Do length again. The range. So three range 10 basically.
3
Yeah, and range
range forward slash.
as the same thing you had the first time. Uh, no. Erase those two not equals, and just put backslash D again. Okay, now
Oh.
try it again. Okay, so what this is doing, okay, so you're using the range 10 as like the numbers 0 through 10, but you're using the dyadic version of range to make windows, which is to say, break the list into groups of three of a window, like, zero, like the first three elements and the next three elements. Do you see what that's doing?
Hmm. Yeah.
You gotta click explain and then run after there you go, perfect. So because it's going right to left.
Mm-hmm. So I get this gets to 10, and this one is like, okay, the left of this is 3 range, and the right of this is 10. That's how I read it, right?
Highest to lowest, basically. So range 10,
Mm-hmm.
and it gets called into three range, but it's Windows. So monotically, or what do you call it? Unarily, it's called the range, but dyadically, it's called windows. Or binarily, it's called windows.
Okay. Okay. So, I don't think I get it. So if I just do this
Yeah, that's
second
great.
one parts, fine. And then if I do 2, okay, it's 2 windows. Windows of 2, so it's 0, 1, 1, 2.
Yeah, windows of 2.
Okay. 0, 1, 1, 2 till 9. Okay. So it's grouping. But
Yeah, sort of. Yeah, please, all these questions are good. So everything you've said so far is good in terms of questions. So please continue.
I don't know how is this. So when we did this, it threw an error which said length of W must be at most rank of X. So does this have any meaning?
I'm pretty sure that's an empty. I'm pretty sure that's an empty empty result. Don't quote me on that one.
Okay. It looks. I mean, it's doing something. So
Yeah.
what's not clear to me is like binary version of this is using 2 of these. I mean,
Well, here, maybe we can simplify it. We can get rid of the right side of the range and just replace the range 10 with numbers 0 through 10 with strand. So like 0 / space 1 / space 2 / 3. Like manually count out / space to get the strand.
oh,
You can do as many as you want before you get bored, but the
Yeah.
points sort of stand.
yeah. Okay. Ah,
Does that clarify a little bit?
okay. Yeah. Yeah. I mean, it was just getting. I mean, it's getting blurry to me. 2 of these.
Yeah,
No.
no.
Okay, got it. And this makes
Yeah.
it clear. It
So
just
we get-
happens to be the same operator being used.
Exactly.
Okay.
Because pre-call, we were talking about how many functions there are, and I said, well, there's only a few characters, but there's like hundreds of ways to use them, sort of thing. And so all these primitives have 2 overloads. There's the 1 argument version, the 2 argument version.
All of
And
these.
in this case, all of these,
Okay.
every single one.
Even the
So, like-
not just the green ones. Even these.
Well, those ones only have 1 or 2 versions. So like the pink ones are 1 argument versions. Actually, that's not true. No. So those are 1 modifiers, but they can have different arguments to the functions they build. Like for example, fold. Fold takes 1 function, but its 1 function can have an argument after the starting value. Remember?
Okay.
So it can return a function because those build functions. So
Yep.
the
Yep.
fold takes a function, and the function that it returns can have 1 or 2 arguments.
Okay. Got it.
Okay. And you're hovering over the constant modifier, and that just takes a value and returns like a function, like
Yeah.
the identity function sort of. So it takes a value and returns a value no matter what you give it. Constant in Haskell.
no-
Constant.
No.
Okay.
Not the identity one.
No. That's not identity. That's like it's const. It's
Yeah. Ignores the first and gives you the second one.
yeah, sort of. Like if you do 2 constant 10 or something, it'll give you just 2 back.
Or 10 back. Oh, it gets 2 back.
No,
Okay.
2. Just 2. It comes in handy sometimes, but
No, I've used const
But it's-
quite a few times, so I know that it has
okay,
its own-
yeah,
Okay.
the general semantics. Yeah, it's good. Weird edge cases, whatever. Cool. So you're asking about bind. So in this case, what we're doing with our windows here, we're doing windows of 2 of the ranges 0 through 10, right?
Yeah.
So you'd read this like I said, left to right. So 2 windows over the range of 10.
Yeah.
But the bind, the left thing you're asking about, which is I think \k or h, is sort of like a pre-process of the value. So whatever function you're doing, you're gonna pre-process the left argument first. So
Yeah.
let's how do we if we get rid of the 2 and put the bind between the 2 ranges,
Like this.
Yeah. I don't know if this will work how I'm thinking, but let's try it out.
Okay, let me try to. I think I understood when
Yeah.
you first said that it's like partially applying. So when I did the one bind plus, now that's
Yeah.
actually burning. Yeah, it's applying the first argument and is waiting for the next one to come in. So it if I understand correctly, uh, sorry, this didn't work. I didn't mean to actually
Yeah.
execute it.
No, no. Yeah, it's me messing up again. Not you.
So this, if I understand correctly, gives a function
Yeah.
that takes one argument and adds one to it.
Yeah.
Okay.
Yes. Because in this case the one
Mm.
is
Mm.
because a value is when using a function is turned into a constant function that returns one. So in this case, the one is actually a function that returns one. So yeah, so you can think of it as partially applying. It's a little more tricky than that, but in this case, it
Oh.
functions identically to that.
Oh, so you said everything is a function. So a number is also a function which just returns itself.
Yeah, I said everything's an array, but in this case, yeah, this is a number too, a function.
Oh, sorry. Everything's an array.
No, no,
Okay.
yeah,
Mm-hmm.
we've there's all kinds of wiggles around that, but yeah, exactly. So if you do
Mm.
like 10 bind plus, you'll whatever you get, you'll have a function that adds 10 to whatever number.
Okay, got it. Understood. So, uh, let me try to guess like what you were trying to do.
Yeah.
Mm. So
I,
you've got two versions of this. So in this case, so I guess you were ranging. I mean, you've got this. Oh,
uh-huh.
so maybe we were trying to get like 0 through 1, 0 through 2, 0 through 3, bunch of them.
Close. I was trying to get 10 boxes of 0 through 10. So I was trying to get 0 through 10, and then another window into 1 through 9 with wrapping a 10 and stuff. I didn't do it correctly, but we can instead of this version, just do
Wait. Let me try this.
yeah. Yeah.
This. I don't know if brackets are needed here, or maybe not. No, it doesn't work out.
Okay. Well, that's closer actually to what I was thinking. But if you do length instead of the very first, the leftmost range number, so yeah, change that left side, this one to length, the not equals,
Yeah.
and then now put your range back in. So
This one.
this should do what I think it was going to do.
So
Did it still
this one
fail?
is this one is the window operator because it's partially applied to one of the things, right?
Yeah, yeah, close. So remember how we had the first time we had like three or whatever, 3 or 2 on the left side of the windows?
Yeah, yeah.
Yeah, and this time we don't have a number. We're partially
Yeah.
applying with a function, sort of thing. So it's going to run that left function on whatever you give it. And what we're giving it is an array of. Well, yeah, I'll let you think about it more.
I mean, argument to this is going to be a number. On the left, we have a function. So I'm not really sure how it's gonna work out.
Yeah,
But,
that's reasonable.
so it actually gave two-dimensional. It gave us a matrix.
Yeah, it did. But
Why did it do that? So this is the length operator, and then this is the window.
oh, okay. This is again me. Put friends around the range 10
Wait, so
once you're.
if I understand
Yeah.
correctly, this functions the same as without this operator and without the parentheses.
It depends on the context.
Yeah, it's working the same
So-
way.
So
Then
yeah,
if
because
I-
you've bound it, you've
Yeah, it's the same way.
yeah.
Okay. Yeah.
Okay. Now wrap. No, you shouldn't have to actually. Uh, the idea was to calculate the length of the array and use 10. So if you change that 2 to a 10, what does it look like? I guess. Because now I'm confused. Does this look the same? Is this the same output as if you evaluate this?
No, it
Oh,
gets like windows of 10, right? So it's 0, 1, 0 through
yeah.
9, 0 through 9, 0 through 9. Oh, but only one of them.
Oh, oh, I sorry. I thought when. No, actually, I'm even more confused because I thought what I expected to happen, excuse me, was to have 10
Of
rows, but it's
these
actually
rows,
showing
right?
you, yeah,
Mm.
it's Windows 10 long until you see all the numbers. So that's what. So this is a 10 element window, and
Mm.
because there's only one set of windows needed, that's why there's 10. So if you put length back here, it'll behave exactly the same. So if you erase the leftmost 10 and put the length back, it'll behave exactly the same because
How
the
is this
length of
working
the range
though?
of 10. Yeah, yeah. So the length, so what the valuation order is calculate, 0 through 9, like get 10 through 9.
Mm-hmm.
Then before calling Windows, calculate the length of its argument. Told you we're gonna get complicated.
Oh boy, yeah. Uh, I don't think this at this point. I don't think this explain is actually explaining well to me.
Yeah.
I'm too dumb to understand it at this point.
No, 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 not too dumb at all. This is a new concept. So get
Hmm.
rid of the bind and the range, the leftmost range, and we're just gonna do the length again.
Bind and wait,
The
wait.
Windows. Yeah.
So we'll give it a number. Fine.
No, no, no. Just only call length in the parentheses. All we're gonna have is length.
All right, actually, let's paste this and here.
Yeah, yeah. Just put length.
Hmm.
The length function, the not equals.
Okay.
Perfect. That'll give you 10. So
Yeah, yeah,
remember
because
how I?
it's the size of the array. Yeah.
Yeah, exactly.
Mm.
And that bind function,
Mm.
that the bind arrow thing, is calling the length first and then passing that to the left argument of 10 of Windows. So it's not partially applying it here. It's pre-processing in the commented code.
Oh, huh. So it only applies once and then.
Yeah,
Oh, actually, yeah, that is weird to
yeah,
me, at least for now.
yeah. No,
Hmm.
this whole paradigm is weird. That's what's so cool about it.
Hmm. Okay.
So, okay, let's do the one level further. Okay, wrap
Hmm.
the length function in a parenthesis again. Okay, and then do on the left of the length.
Let this be a
Do
quiz.
okay. I don't know what that means.
No, let this be a quiz. I mean, like, I'll try to
Oh,
guess.
sure. Okay, so
Hmm.
on the left paren you just added
Yeah,
to the right of it, do just do 10 plus again if this compiles.
like this.
Yeah, let's do 5. Sorry, 5 to make it easier to compare the two numbers, but 5 instead of 10. Yeah, and this is a quiz.
Okay.
Assuming this compiles,
Uh,
because we're I've been
yeah, yeah. So, yeah, I think it's 15, and it's going to try to make the windows of 15. And how many windows is it going to do? Maybe just one, and then it's going to repeat the 0 through 6. So it's going to be
okay.
one row, and after 9, additionally 6 elements,
Okay.
which
I think
are
actually
two.
you got it right. I think I'm wrong because I think we'll just fail complaining thing, but I think it's a
Hmm.
reasonable thing. If you change it to minus swap instead, we can try that instead. Instead of plus, just change it to swap minus.
Wait, I didn't evaluate it. Should I try
No,
evaluation?
no, yeah, sure, go for it. I think you got it right.
Okay.
Yeah, it's gonna
Window
complain.
length
Yeah,
W
because
must wait.
15, 15
Let me
is
try to understand
higher
this.
than.
Window length W
Okay,
must be
okay.
at most axis length plus one.
Yeah,
Ah, Ah, yeah. So of course, like you cannot have a window that is bigger than the array itself. Okay,
Exactly,
fine.
and you got it exactly right. So now do
So
minus and then do swap.
minus and then swap. Uh, s-
No shift. Backslash tilde. No shift.
ah,
Tilde is the one next to the one. There you go.
yeah,
Perfect.
yeah, yeah. Okay.
And now
All
run.
right.
Now we should. There you
Yeah,
go.
yeah. The operation was right. Now I just forgot to actually
Exactly.
tell you what's
No.
going to happen. But this, I think I understand. Okay, so
Okay.
so it's going to take this and
Yeah.
apply this to that, and then use this as the first argument to this. Oh boy.
Yes. Exactly. It's composing functions on the fly. And I think that the brain F here is you can, I think, remove all the parens, and then I think it'll work the same. Oh, no, never mind. Some of the parens are required, but that's fine.
Okay, now
The
I
inner,
also have to guess like why that is required.
sure.
So if I do this, uh, this has to be the window, and it has to evaluate length. Okay, it's gonna be, yeah. I think that the thing is, length 10 is gonna give us the one, and then it's going to subtract 5 from everything. That's what's gonna happen.
Yeah, yeah, exactly. It's going to be a one column thing minus 5 on every element.
It,
So remember it's a one row of 0 through 9, and then
yeah.
it's minus 5 to every element in there.
Ah, it starts from yeah. It starts from 0. Okay, perfect. Yeah. Okay. Yeah, I think I understood this.
Okay, good. So that's the left binding. The right binding is the same thing, just the opposite order.
Yeah. Yeah. Okay.
So
So
so you, instead of preprocessing the left argument, you can preprocess the right argument.
oh you okay. So I think this is not gonna compile because this makes no sense, or does it? Oh wait, it might. It might. It might. Oh, I don't think it does.
Oh, I think it will. I think it will. But okay. What do you think it's going to do? So I'll give
See,
you my assumption of what it's going to do.
okay. To me, this one is forcing the evaluation of the right side, and this right side does not really make sense. What is happening here? Oh, maybe it's applying range over these. Oh, okay. Good. Range
Yeah.
on every number, range of 0. So this probably is going to give us a matrix. No, it's not. It's not
Okay.
really a matrix. It's actually a list of lists. So this will give us a list of empty list, and then list of 0 1. Oh no, a list of 0 0 1. I don't know. Yeah, it's gonna be a list of lists, and then this thing is gonna get applied to it. This will bind. Not.
I I think it's a little different. I think it's going to be the range of 10, and then it's going to be uh, the length of 10, so 10, and I think it's going to be minus 5. So I think the answer of the whole thing will be 5. If I'm right, I think the answer is going to be 5
Okay.
because it's doing right to left. So it's going to do the range of 10. Then the next function is length with pre-bound to the range. So it's going to be 10, I think. And then it's going to be 5 minus, like swapped minus 5.
Oh, wait. So how length is pre-bound to this
Yeah,
range?
those three characters that you had highlighted are what is going to be one function.
This is this is like the function with the operands.
Yeah, I think so. The binding to the right there is taking these two guys, making a new function.
So what is this function equal to? Is the that really doesn't
It's
fit the
gonna,
problem. You're saying it's 5, right?
you know, I think it's gonna be 5. I could be very well wrong, but I think it's 5. I think the answer is fuck.
Argument
Shoot.
shape
I mean, I think the answer is 5.
argument shaped prefixes don't agree. Yeah,
Okay.
I mean that's what I was guessing, because maybe what I guessed was not really why it's wrong, but to me, evaluation of this thing doesn't really make sense.
Well, here, let's simplify. We can put a show before between the two ranges, between the two arrows. You can do a show, yeah, with the but put them between the two arrows rather than uh,
Oh,
like yeah, length bound to arrow show arrow. Yeah. 0. There you go. So that'll be the numbers 0 through 10,
yeah.
which makes sense.
Mm-hmm.
Then it's doing. I'm pretty sure it'll just do well, that won't work. You got to get rid of because it shows just the function, and bind can deal with functions. You're binding show to length.
Okay, got it.
Yeah. Oh, okay. It is calling it maniacally. Sorry. So, okay, do get rid of everything to the left of your cursor for now. We can bring it back after. So this is what's going to happen. You're going to see that it's going to do weird. It's going to be weird length stuff. You'll see. It's going to be like a 0 and then a 0 1, 0 1 2 is my calculation. No, I don't know what I'm talking about ever. Great. Great.
So what happened here? It says range.
I don't know.
Let me. My assumption for this was that it's going to give us the array of
Well,
arrays.
this is what we just ran, isn't it? Yeah.
Yeah. Without the show, of course. So
Yeah.
I don't know what's happening here.
Well, this is just a list of 0 through 9, or 0 through 9, but because it's zero, imagine it's 0, 1, 2, 3, 4. That's all it is, and it's the range of it. But I think it's an empty range. If you put on the very first line, if you put a character, sorry, very first character, if you put the shape of the / shift M for shape, this should be 10, right? Yeah, it is. It's 10 empty ranges. So this is basically a 10-dimensional array, is what it's giving us, with 0 elements in each of them.
Oh.
And we can fact check that by doing get rid of the /M thing and do length. So /quest / the length one, and then each /2, and it should be 10 zeros if I'm right. No, okay.
There's really a lot to take in here. Okay.
Yeah.
Yeah. What's the most interesting program you've written in this?
Well, I have a back testing trading bot thing. It's like 500 or 1,000 lines of BQN. It basically reads a CSV and then
500,000 lines of this?
No, it's 500 or 1,000 lines. Like it's not huge, but it does a lot of stuff. It basically reads in a CSV, does some time processing, and then does some like trading on, or not trading, but like simulated trading on stuff, just to figure out what numbers would be, and then prints it out to a nice grid after. We're getting stuck on like some earlier stuff, but it's pretty. It's pretty quick to move around once you're in the flow of it, which is really nice.
No, this is purely coming from the fact that I am trying to experiment certain things, but I know that you can be pretty productive because it doesn't take that long to actually understand what each of these symbols does, and
yeah.
It's definitely an interesting way to program. From Code Report, I've heard that, I mean, these languages are popular in the code golf space, where we want to solve a problem.
Oh yeah,
with the least amount of characters.
I
also see that it's 14 characters. It actually shows here.
Yeah, yeah.
Okay.
Yeah, like, it's always fun to shave. So, like for example, I could paste. I don't know if it'll work actually, but I could paste in the. I wrote the what's it the hello world thing you got asked with the numbers and then the get line input thing.
Mhm.
Um, I wrote that and it was. Let me see if I can find it if you want. Otherwise, we can move on or
I
whatever. But
think, yeah, I think I have it. Two timestamp. Was it that one? Was it
I
this?
don't. I don't. No, no, no. This is some. This is a library that comes with basically to do time processing. So you give it like a Unix timestamp, and it'll
Oh,
do it'll turn a like a one two like a 10,500 whatever to the year 2024, for example.
okay. Can I run this stuff?
Yeah, it should run it. Yeah, so it exports the two names to timestamp and from timestamp,
Okay, got it.
and
Cool.
then when you now after this you just call like from timestamp and give like today's date or whatever. Uh, Here, if you in in YouTube chat, I'll paste in the number,
Oh,
and then I think you do from timestamp or to timestamp at the very end here.
like this or
Capital F because it'll be a function.
eh, oh, this is
Like, yeah, exactly like that. Only the first character matters, and then with that number, I paste it into the YouTube chat.
oh, only the first character?
Only the first character matters for capitals. Yeah.
Okay. I don't see your YouTube chat.
In no, okay. That's weird. I'll paste it into our Discord chat then. But it's just a large number.
Mm-hmm. Okay. Let me take.
Do you have it now from Discord?
Yeah, got it. So I just need to paste it
Just
here.
pass that to yeah from timestamp. Exactly.
Maybe
Do
two
two
times.
timestamp instead.
Hmm. That will
What?
work. Two times damn.
That should have worked.
Hmm.
If you scroll down, it was at the very end of the file. Is this at the bottom of the file?
Yeah, that's the bottom of the file. Maybe before export? No.
No, yeah. Can, okay, replace timestamp.2 to with two timestamp with timestamp.2. I don't think this should matter, but maybe it does for some reason. Capital T
Capital T.
on the two.
Yeah.
Capital T on the second T, not the and lowercase t on the first one. Sorry. Yeah, it's weird.
Is
I
it?
don't understand what that's about.
Is this not applying the function to
Well,
the?
it looks like it. Yeah, it looks like it's not. But this is just I don't understand what this is trying to do. I've only ever imported this file and it works fine when you import it.
Oh,
At the very top of this,
to timestamp and from timestamp. These are the exports, right?
yeah, yeah. But
Oh,
that should have been.
maybe. Yeah, yeah. I mean, I don't think this is an important thing, but it's just some way. This is maybe meant to just import stuff, and you can't really.
Well, no, I would have expected timestamp two to work, or whatever. If you do show 123, does that work at the bottom of this file? Like if you do just a normal function, do we get output we expect?
Hmm.
Yeah, that works.
Yeah.
Oh,
Maybe.
we didn't. Of course, show this because show the result of two timestamp
Oh.
because this has an export, so the returning things is going to be the namespaces we export at the top of the file.
Okay.
Okay, so
Show.
now do two timestamp with a number, two timestamp, and then the number I pasted in. Yeah, perfect. We just get rid of one of the functions.
Oh,
There we
nice.
go. Okay, yeah. Okay, yeah.
Okay.
There you go. So it's a 6 element array, whatever. So if you want the month, like so, if you want to take the first three elements, then you get the year, month, whatever, and then the rest of it is the
Hmm.
day.
Okay. Okay. Cool. And
Yeah.
what about these red ones?
So red is just the minus negate, like that's just the minus, because you want to like as if negative numbers. That's how you write negative numbers.
How is this different from the green minus?
So the green minus is the negate or like subtraction function, where this is the red minus is like the number, the value -1 or now negative whatever, rather than minus.
Oh, you cannot use it without a number.
Yeah, pretty sure.
Ah, okay.
It's
Okay,
yeah.
got it. So I cannot. Oh, so you can use it. What does this?
Well, that's the negative. So yeah, if there's the negate function, which is the minus character, and then there's the uppercase minus, or the upper minus, which is how you do negative numbers in the first place.
Oh, these are constants. Look like.
Sort of, yeah. I don't know whether the minus specifically is a constant, but yeah, there's pi and infinity. The at is a null character, so it's like it's the zero, the backslash zero.
Okay.
Hashtags comment, quotes is characters and strings. Strings are just arrays of characters. Characters are just formatted numbers.
Yeah. And then what about these?
So these are used for functions. So we can do this quickly, I guess. If you want to make like a function called foo or f or whatever, do capital F.
Yeah.
And then assign it to the result or whatever, like the backslash brace.
Okay.
That one, yeah. And then curly brace. And then do backslash S or shift S. Probably shift S. And then do like arg1. Just call it arg1. ARG1.
Okay.
Perfect. And then change the left paren to a left brace, left curly brace. Both these are going to be curly braces.
Wait, like this?
No, the it's like a round parentheses. I want the like the pink ones right above your cursor. Those guys. What do you call those? Yeah.
Curly brackets.
Brackets? Okay, curly brackets. Yeah. So instead of parens, we want curly brackets.
Oh, both of these.
Yeah. Perfect. And then after the 1, do colon. We're defining a function is all we're doing here. And now this is the body of the function. So let's say like arg1 plus 1 or something.
Okay.
So now we call this function. Yeah.
Okay. Got it.
So we named our arg here. We named our arg1, but you can replace s all the way to the plus with just x to have an anonymous function, or anonymous argument. So take the s and all the way to the plus, and replace it with the x. A lowercase x.
Oh, and what's the difference between the lowercase and the uppercase?
A function versus a variable.
Or versus it's the same one.
Value.
Okay, got it.
Yeah, and then get rid of the colon and arg1 as well, because we're going to get rid of everything. And now we call this.
Oh, it's just got it.
Yeah. And w is the left one. So if you want to have a second argument to this function on the left side, you call it w instead. So you do like x plus w in the body. And then on the left of our f call, put like 10 or something on the second line.
Oh. Okay.
Yeah. So with the s and the colon there, you can name it, or you can just have it implicit, automatically named.
And then the f and g.
So if there's a modifier, so how we have our bind and our eaches and stuff, those are modifiers, and those modify functions. So you can have f and g being the left and right functions it's modifying.
Okay, so if I I know this is syntactically incorrect, but if I have this, then f is expecting the left-hand side to be a function, right?
Yeah.
Okay. Maybe I can do... Wait, let me just try this. So if I do wx like this, and then I can give 10 plus... Oh, because it cannot... Left argument required. maybe like this. Second level parts of a train must be function. Do I do this operator? I don't think that's gonna work.
So I think you need to pass in a. Well, no. I think it'd have to be a modifier. I think so. W is a value that it's taking in, and you're calling it as a function. I think that's how this works. This is a little weird. So, but if you call it F instead of W,
Like this?
the funky F, yeah, that one. That should at least be a little more complaint, and they'll put underscore is perfect. So, custom defined names have to have sort of capitals, have to be functions. Modifiers have to have underscores on the left. So put a left before the F, left underscore. And then same with when you call it. Okay.
Oh, wait. That's not really what's happening.
Well, then now swap your right bind to a left bind or whatever it's called. The 10 thing, yeah, change that to the left side, to the right side. Wrong one. There you go. That should do it. There you go.
Wait, but what happened? So two things. Why did I have
Yep.
to put the underscore here?
So remember how lowercase is variables, uppercase is functions?
Yeah.
Underscores is how you do modifiers. So one underscore on the left is a one modifier.
Oh, so higher order function.
Yeah.
Okay.
Because it gets parsed differently and stuff.
Okay, got it.
So in
Understood.
BQN, all these. Okay.
No, sorry. But you still, please explain. So.
No,
Just for the
okay. No,
audience.
there's a. I think it's delays. No, it's okay. There's a delay. So when I'm talking, and you can start. It's anyway. So in APL, there's no syntactical difference. Like a function can be called capital F or lowercase f or underscore f. Doesn't matter. But BQN is a little more strict than that, where it knows upfront if it's going to be a modifier or whatever, just based on the name.
Okay.
That's one more a little different.
Okay, got it. So and then. Why didn't it work with the left bind? Sorry, right.
Because you had bound. You had bound plus to the right argument of 10. And because 10 is a constant function that returns 10, no matter what you give it. Like you're giving it the conjugate of 1, which is 1 still, I guess. And you return 10. We can play with that more if you want. Like, change that instead of a plus function, change it to like length or something, or some other thing that won't give out just a 1 back. Like whatever function you give it here will still return 10, because 10 is a constant function, and as you said in OCaml, const or whatever just returns the same argument over and over again.
Okay. So how can you just repeat how that happened? So I bound right binding to this.
Yeah, because 10 is a function. So in this case, so now you're saying whatever you're going to pre-process the left argument to 10 with length. So whatever you're passing it is going to be the length of it, and then the result of that is you pass to the function 10, but that's going to be still just 10.
Oh, okay.
Whereas if you swap it,
yeah. If I swap this, then there's the left part is going to get evaluated first, right?
Sort of. This is now a partial application almost. You're saying almost. You're saying the left argument to length here is 10. That means it's going to be the not equals primitive now instead of the length function. Okay. And you're going to say 1 does not equal 10, basically.
Yeah, it's going to be false.
Yeah, which is, of course, true.
Oh, so it doesn't have booleans.
Right, it doesn't have booleans. It has bit masks.
Okay. Yeah.
Or not bit masks, but boolean masks.
Okay, got it.
Do you have time for more, or are you done?
Yeah, I think we're good. This was
Cool, cool,
interesting.
cool.
This is my first time dealing with an array language, apart from just saying
Yeah,
some simple programs. As I told you earlier, right? Like I used to watch code reports and some other solutions,
yeah, he's
but
great.
didn't really get into them. But yeah, I think this is cool. But I
No,
don't really see an application for these languages myself yet.
right,
But
right.
I'll probably attempt solving some problems. Uh, maybe lead code or something.
Yeah, leak code or like I said, Evan the code is really good because they're normally numbers and characters anyway, so it's really good to begin with those.
Okay.
Or I did. I began with them, and I'm really happy I did. If you do those at all.
Yeah, I think Advent of Code is going to be really interesting. Maybe we can do the next stream where I can attempt to
Oh, try solving.
solve.
That'd be
Yeah,
awesome. I'd love that.
yeah, yeah. I don't think I'll get past part three. Sorry, not part three. Day three. I don't know.
Oh,
Uh,
but
yeah.
with how fast you did this, man, I think you've got the right headspace for it.
Okay. Yeah. That's
So if
that's
if you
thinking.
ever mess up, it's basically my fault, is what I'm saying.
Yeah. Doesn't really work that way, but yeah. Thank you so much for the introduction. I had a good time.
Yeah, it
And
was good. I had a lot of fun.
all right. I think we're good to end the stream then.
Sure.
Cool. Thanks for joining. All right.
All right. I'll see you later.
Bye.
Bye.